All right. Hello, everybody. Thank you for joining wherever you are. Good morning, good evening, good afternoon. I am Josh, and we will be starting this webinar right now on From Code Intelligence, securing a GraphQL API. So we're going to talk about GraphQL, talk about how it works, what it looks like as an API structure, and talking about securing it. So kind of thinking about it from a security perspective. And thinking about how to keep that API nice and secure. Your speaker today. Hello, I am Josh Grant, a developer advocate at Code Intelligence. I'm joining you today to talk about things, a little bit about myself. I am a test automation specialist by training, and so now I'm happy to be working at Code Intelligence as a developer advocate, advocating for all the wonderful things that we do, fuzzing, security testing, all these great things, helping you with all of your AppSec needs. And I am located in lovely Toronto, Ontario, Canada. So this is a little picture of the beautiful Toronto sign and the so-called new City Hall. So let's jump into it. So let's talk about web APIs. Obviously, if you are any kind of developer nowadays, web developer, or even if you have internal services and you're working in an enterprise, you probably will encounter some kind of web API to connect to do some kind of task to either send or retrieve data from a database or HTML or something like this. So, and you'll probably encounter this at some point in your career. So let's talk about the web APIs. So suppose you want to build a web API to connect your backend services, right? And so let's say you have to connect to a web front end for a SaaS application or for some kind of web kind of front end. Maybe you also are building a mobile app. Mobile apps really under the hood connect to a lot of external services via APIs, or you just want to use something internally. So maybe you have a team that's a team kind of in your organization that has a service that you want to use, and you need to connect to it somehow, or you have to make use of their APIs. So let's say you want to build, for some of these scenarios, very common in the software development world. So you have choices. So before you even start, you will have like plenty of choices to in terms of architecture, so how you want to think about and build out these API services to connect to your lovely data. So choices. So here are four, maybe the four only choices that you have for connecting to these services: REST, SOAP, gRPC, and GraphQL. So let's talk about REST. So REST is by and large the most commonly used kind of architecture or form of web APIs. You're probably using one. You've probably used one very recently without even knowing it. Highly common. The idea of REST is that it's very much based on the statelessness of the web. So you send and receive. You send requests. You get responses. Requests and responses both kind of follow JSON, kind of the JSON serialization format, by and large the most commonly used. If you are in an older enterprise, you might come across SOAP. So SOAP is a different style of web API based on web standards, and in particular XML. It leverages heavily on XML. Very different flavor from REST, but SOAP does have the advantage of having several more features. So for enabling things like security or authentication, or like different data formatting type things, SOAP does offer more features out of the box, whereas REST is a lot more lightweight. gRPC, I'll very briefly talk about, kind of a new kid on the block, comes out of Google. It's based on using the HTTP 2 protocol as opposed to HTTP 1.1. And it's kind of highly built on sort of a new flavor of web architecture. So it kind of leverages things like multiplexing, sort of parallelization, concurrency, that kind of thing, to kind of take advantage of the modern web. And last and certainly not least, since we're talking about today, GraphQL. So GraphQL originally came out of Facebook several years ago. and now is kind of managed by a foundation. And GraphQL is very query based. So the idea of GraphQL is to think of querying a backend, and to think of it almost like SQL or some kind of data querying style of format. So that's the one we're going to talk about today. We're going to talk about GraphQL. And so let's just get into it. So as I mentioned, so GraphQL is a query-based API. So requests follow a query format and responses are in JSON. So in contrast to REST, where you would make a request that's formatted in JSON, maybe with some additional headers, GraphQL is based on making a query, a query based on a schema that was defined ahead of time. And that query will return data or update data on your backend. So it's very much like a query data-driven style of API, where you can kind of retrieve data. As you might imagine, coming out of Facebook, GraphQL is designed to be highly performant and handle large and small requests for retrieving specific data. So if you're looking for something, if you're looking for data and you're trying to retrieve something from like a very large data store or backend or database, GraphQL is somewhat optimized for that. All right, so GraphQL requests must follow a given schema. There are specific queries and specific fields that are allowed and that are required based on a defined schema. And so requests can only be one of two types. So GraphQL does follow all those lovely HTTP standards, making get requests, post requests, that kind of thing. But in addition to enforcing a schema, requests can only be one of two types. So a query, where you're querying a data and trying to retrieve data given a query, or a mutation. So mutation is where you talk about things like edits or inserts. So you're either updating data or you're inserting new data. Interestingly enough, GraphQL is optimized for reading data and less so about deleting data or doing wholesale edits. Unlike REST, like a REST, you can make a delete request and delete things, drop tables, all those scary things. GraphQL is more oriented to reading data itself. So again, if you're trying to read a lot of data, GraphQL could be a good choice. Okay, so how does this compare to REST? I'm going to use REST as a baseline comparison because it is the most common architecture, the most common format for web APIs. As I mentioned, there are other ones, but let's talk about GraphQL in conjunction with REST. So suppose we have a service worker working with users on a platform via the user endpoint. So let's say you have to manage users somehow. You have an HR system, or you have some kind of platform where you have lots of users, and you have a user endpoint. So, or you have some kind of user concept or model. So user endpoint, here's how a REST implementation might look versus a GraphQL implementation. So let's start with the classic case. So here is for my cool service.ca has a user's endpoint. So here's how you might add a new user via curl. This you could also imagine using your favorite API client or REST API client, or something like this, but curl is kind of a lingua franca. So we're going to make a post request. We're going to post new data. We want to add this new user. We pass in like the header. In this case, we're going to pass in some kind of JSON, right? We have some kind of application on the back end. And our data looks like this. So we have this JSON object, and we have some fields: name, role, age, an active user. So we're adding this new user named Andy Anderson. Andy Anderson has a role of a software developer, age 30, and Andy Anderson is going to start as an active user. Maybe there's a concept of inactive users, something like this. So some things to point out. So the data passed in is in a JSON format. You have this user's endpoint, which is defined specifically for handling user data. Maybe you can also make a GET request. Maybe you can make a PUT or PATCH request as well if you want to read data back. You want to get all users, a list of users, that kind of thing. Something else to point out, in addition to this being, is that we have some formatting. So we can have fields that are strings, fields that are integers or numbers, and booleans. Okay, so pretty straightforward. You've probably seen this. So let's look at how this might look in the GraphQL case. So here it is. It looks very similar. Again, we're using curl. Curl does support various API architectures, including GraphQL. So you can hit a GraphQL service with you can hit a GraphQL service with tools like curl. So that's helpful. And this does look very similar. So we have a post request, again, very standard, a header, and we have a query data object. So this is not standard JSON. We're now making this query. We're passing this query request. So what are some things that we can point out? So let's kind of go step by step. So one is that we are, so in addition to this data not being a standard JSON object, it's now a query object, something defined by GraphQL in the schema. So first, we have to specify the query type. So as I mentioned, you have to have one of two types. You can have a mutation or you can have a query. So mutation mutates data. So either updates or adds new data to your data source. And you have to specify that up front. So this is a part of the GraphQL specification and the GraphQL formatting. And so here we're specifying a mutation. So we're adding a new user, we're mutating our data, so we have to specify a mutation. Also, predefined functions. So again, GraphQL enforces a schema. Unlike REST, REST kind of hinges very much on the statelessness of the web. If I make a request to a RESTful endpoint today, it might be different than tomorrow. So that's similar with GraphQL, except that GraphQL does have a schema. So the schema does define the sort of actions you can do. So the type of queries you can execute. So here I can do a mutation, but the mutation also expects, or the query rather, does expect some kind of function that the schema provides. So in this case, I'm able to save user. If I've defined the save user in my GraphQL specification, my schema, I'm able to do this. All right, so those are two of the bigger things. It's not just standard JSON. We have these additional concepts. And also fields to return. So again, if you think of this as a query language, you make a request. You want to also ask what data you want to retrieve. In the REST case, you'll get back response. The response could look like various things, all sorts of things. It will be valid JSON, I think. 99% sure it'll be valid JSON. In the case of GraphQL, it will actually be you'll retrieve some data. The data will be in JSON, a JSON format, but you can also specify which fields you'd like to return. So in this case, we're adding Andy Anderson. And again, we're adding name, age, role, and active user. We're able to use these same data types, whether it be a string, whether it be an int or a number, float even, or a Boolean. But we also have to specify what we want back, if we want something back. So here we actually just want to get these values back, including the ID. Again, thinking of things in terms of data and queries, IDs might be automatically appended onto our data back. So Andy Anderson will automatically get some kind of ID generated by our system. It could be a UUID, could be an int, could be something else. So something like that. Oh, and one last thing, I know, sorry for the back and forth. The last thing I want to point out is this GraphQL. So in the REST case, we have a user's endpoint that's specifically for operations involving user values or user data. Here, there's this common endpoint. So every GraphQL service has this GraphQL endpoint, which is an entry point for all queries. And so when you send a query request, whether it be a query or a mutation, you're using this endpoint. So this endpoint is a single endpoint that all query requests go through. So a slightly different flavor than REST. On the one hand, it's good because you have a common endpoint. You can always use it as a consumer. But on the other hand, you have to know something about the mutate or something about the schema as we go on. Okay, so that's kind of the quick and dirty overview. So what are some of the advantages of GraphQL? So the obvious example is it excellent working for structured requests and data. So the case in a lot of web development, a lot of web applications in their heart are really just CRUD applications. You're managing data, you're creating, reading, updating, and deleting data. And so APIs are often really just thin wrappers around SQL databases. So your API, whether it be REST or SOAP or something else, is really just updating a database or retrieving data. So GraphQL takes advantage of this. GraphQL says, well, let's just build in the idea of querying data into the actual architecture of the API. And so let's do that. So if you're working with data specifically, you're working with CRUD data, you're working with a database almost directly, GraphQL is excellent for this. Another advantage is that GraphQL really works hard to guarantee the immutability of data. As you can see, because you can only really make queries and mutations. First of all, it distinguishes between reads and writes explicitly. REST, for example, does not do that. You can just send a request and hope for the best. So GraphQL kind of works on immutability and sort of data integrity and immutability. But also there's no explicit way to remove data or delete data. It's not built into the architecture. So it's excellent for reading data. And another advantage is that the schema for your GraphQL API must be defined up front, right? So changing the schema breaks the API. So this is an advantage because you have an idea of what your data looks like, what kind of requests you can make, what requests are available, and so on and so forth. So these are some advantages, all about data, all about querying data. So that's very good. So what are some disadvantages? Well, it's not as common as RESTful services. As you can see, it looks different. So tooling and development differ from common REST frameworks. Like for example, if you're used to REST, the requests look different. Requests have a different feel. You can't simply just sort of tack on data and make a request and hope for the best. You have to know something more about your system when you're using a GraphQL API. But also, it's just not as common, and the tools are different. So, for example, if I told you, like, well, our backend is a Django backend in Python, you kind of have an idea of how that works. If I told you that it's a SOAP-based architecture in .NET, you maybe would have an idea of how that works. GraphQL is sort of a little bit newer, and maybe people aren't as familiar with the tool stacks. So another disadvantage is required knowledge. So there's a bar to meet in order to make valid requests and retrieve data that you need to know. So REST has this problem as well, of course. If you don't know what the APIs are, if it's poorly documented, if it's not really meant for like consumption by you or something like this, it can be tricky. Tools like OpenAPI specs do help with this in the REST case. But there is no analog necessarily in the GraphQL world. So you have to understand the schema. You have to know what functions are available. You have to know the tooling very well. So it can be a hindrance if you're kind of generically working with a new GraphQL service. And a disadvantage is the schema must be known up front, and changing the schema breaks the API. So for example, if someone, and so because the schema is defined within your framework, it is code. And so if someone makes a change to the schema, without you knowing it as a developer, and someone tries to push up that change, a change in the schema could potentially break your application. So you have to be fixed up front. So it's another layer that has to be managed. So it's helpful. And having a schema is helpful for being able to understand what you can do with your data, and how you allow, as the backend developer, it lets you control how people access data and what you can do with your data. But a disadvantage is that you have to manage that now. And so changing the schema could break things, could cause unexpected results. And if you're a consumer of a GraphQL service, then you still have to understand the schema. And if there's a schema change, you have to be aware of this, or else your services won't work, or your requests won't work. All right, so now for the good bit. So securing a GraphQL API. So what are some practices? So first off, testing. I would be remiss if I didn't mention testing in general. So do you have a testing strategy? You do you, right? How are you testing your GraphQL API in general? It's possible to write a schema. It's possible to write endpoints, or not endpoints, but it's possible to write different objects, and how you access those kind of models through various controllers. But are you testing this, right? So there's a couple of ways to look at this. One way to think about it is exploratory testing versus automated testing. This is important for kind of functional testing and product testing, in addition to security. Like, are you able to do exploratory testing, or have you thought about exploratory testing? What can you do with this API? What is revealed through this API? Are there some edge cases that you didn't think of, or something like this? So you can use tools like Postman. Postman does handle GraphQL endpoints, so you can use Postman to set up API workflows, or set up like test cases, or just to explore your application in general. And in addition to exploratory testing, as a developer, you can also think about automated testing. So think about unit testing, not just the kind of core functionality or core business logic of your service, but also your GraphQL layer as well. So for example, suppose you are using Spring. So Spring Boot does support, or I guess I should say that GraphQL has integration with Spring Boot. And it's kind of the Spring Boot ecosystem. So there are frameworks such as the DGS framework from Netflix. You can find this on GitHub. And this is a framework for kind of building out GraphQL tooling in Java Spring Boot. So, and this includes unit testing tools. So similar to Spring Boot test cases, or MVC test cases in kind of Spring Boot in general. This framework, as an example, I've never used it, can let you write unit tests or unit style tests in Spring Boot with a GraphQL service. So this is very beneficial, extremely beneficial, because you can test those basic cases. What happens if you change a schema? What happens, suppose you have a complicated query structure that you'd like to verify, this sort of thing. So testing. This is an excellent first place to look if you're either a security researcher, what tests are written, or if you're an application developer, right? Can you understand what your system is doing? Do you have basic tests? Okay, so next up is the GraphQL endpoint. So as I mentioned, this GraphQL endpoint is common to all GraphQL API services. If you're Netflix, or if you're not Netflix and you're deploying a GraphQL service internally or externally, this endpoint exists and is obviously something to consider. So if it's public, first question you can ask is there a problem here? Should this be a public endpoint? Are there any concerns with being a public endpoint, right? This kind of thing. From an attacker mindset, if you're able to discover that a service is using GraphQL, then this endpoint is available as a target. So keep that in mind. There are other endpoints, such as there's this GraphIQL service, which is present in many implementations of GraphQL frameworks. which provides you like a web-based GUI for queries. So if you want to test that the query works or what it does, this kind of thing. So again, do you want to expose this endpoint for the service? Do you want to disable it? Is there a problem providing this GUI endpoint to general consumers? This kind of thing. So think about this. This endpoint will be available. So like, what should you do with it? Roles and permissions. So one of the good news, sorry, it's almost Friday. Some good news about GraphQL is that GraphQL frameworks do provide sort of off-the-shelf roles and permission systems or role-based access systems. And you can usually implement those at the service level, or sorry, at the I guess HTTP controller level. So if you're using a service like Apollo, Apollo is a popular one, kind of HTTP service server for GraphQL. You can apply roles and permissions to various queries. So that means you might want, general users to query some data, but like administrators might want to query all data or something like this. So there's various implementations based on the framework you're using. But one, you can do this. You can implement roles and permissions in a straightforward way, generally speaking. And two, you can verify these and test these. So, can you make sure like that the right individuals have access to the right data, this kind of thing. Okay. Malicious queries. So similar to SQL injections. So a SQL injection, you can think of as sort of a malicious SQL query. The popular Bobby tables on XKCD is the classic example. There are malicious queries that you can execute on a GraphQL service. So yes, it's much more difficult, if not impossible, to delete data or drop all database tables, which is a big plus for security and using GraphQL. But there are still things that you can still do badly. So for example, DDoSing your system and performance-based queries or performance issues that queries, it's possible to construct queries that could be pathological, like that sort of have like a cyclic dependency, or like return, 9 million, return the first 9 million of these things, based on the first 9 million of these things. And that can either slow down a system, causing issues. You can also DOS your system, denial of service attack, where a certain query is just so computationally expensive, it either crashes the system or makes it unusable. And again, dropping tables is more difficult, but you still think about what people can do to either harm your system, or if there's some kind of dependency or some kind of circular dependence in your schema. So like if I can call all users, but all users depend on all accounts, and all accounts depend on all users, you can sort of trigger this race condition or this infinite regress. So malicious queries, look out for those. And last and far from least is fuzzing. So fuzzing. So two ways to think about fuzzing. Fuzzing a GraphQL API, similar to a REST API, but you can fuzz the service. So you can kind of set up a GraphQL service and hit that endpoint with, a fuzzed query. Maybe some fields are fuzzed, or maybe you have some kind of fuzzed structure, generated somehow. So this is similar to Spring Boot. So if you're in the REST world, Code Intelligence now offers integration with our Jazzer fuzzer with Spring Boot. So if you're doing that, you can use that to fuzz a Spring Boot service. Fuzz a Spring Boot service pre-deployment. So that's very good. You can apply that same logic and that same approach to fuzzing a GraphQL service. For example, if you're using GraphQL in Spring Boot, you might want to see that you can still run the service after being fuzzed. And kind of dropping a layer, you can also fuzz the query functions. So because you're defining a schema, because you define these query functions either in your controller layer or in your model layer, you can fuzz those functions. So like, again, you might be able to either get some kind of pathological or malicious query. Maybe there's some kind of data type issue that you might not see, or this might just help you explore various ways to kind of secure and harden your system in terms of performance or in terms of like malicious queries. So you can absolutely do that. And yeah, we can take a look at that. And I think that's it. So thank you for joining and listening. And I'm happy to take any questions or offer any advice if people have any comments. No questions. Can you go over again what the difference between what fuzz testing and what Spring Boot does? Okay, yeah. So excellent question. So kind of as I mentioned, there's a couple things you can do when it comes to like an API service. You can test at the service layer. So like call your endpoints with fuzz data or like with mocked out data. And so you can fuzz at that level, but you can also fuzz at the lower level. So like fuzz your business logic, your methods, this kind of thing. So when it comes to fuzzing, there are a couple of approaches you can use using CI fuzz. So one is to use CI fuzz directly. So whether you're using GraphQL, whether you're using REST, you can generate fuzz test cases to test a method in general. So you can use CI fuzz command line tool, which is excellent. If you're using Spring Boot, for example, and you would like to fuzz that Spring Boot service, before you deploy, definitely check out the Spring Boot Jazzer integration, which is also offered by Code Intelligence. So if you're using Spring Boot, in addition to your Spring Boot tests, I believe they're called, or Spring Boot web tests, you can also have a Spring Boot fuzz test that will fuzz the service kind of at the unit level. Yeah, and I'm happy to any questions ever. SOAP, QL. Oh, okay, great. Thanks, Mahood. Yes. So just for clarity, so I have done some advanced research projects on large scale graphs, and might be interesting for your works as well. So please let me know how we can talk. Thanks. Oh yeah, great. So yeah, GraphQL. GraphQL. I don't know if GraphQL implements full graphs. Like they're not. They're directed graphs. They're directed graphs that could have cycles in them. But also, if you're interested in large scale systems and fuzzing, yeah, we're happy to talk. My graph theory is a little rusty, so yeah. All right. Well, if that's it, we can wrap up. Definitely reach out. Yeah, definitely we will reach out. Please check out CI Fuzz, the CI Fuzz project in Code Intelligence. And also if you go to app.ci or app.codeintelligence.com, log in with your GitHub, take a look around, and then we'll be in touch. Yeah. All right. So thank you very much and have a good day.